For this demonstration, I have taken two waveforms. So the waveforms are generated using a signal studio, and then you can set it to different bandwidths like 100 megahertz and 400 megahertz, and then export the waveform. And then those waveforms are loaded into the ARB. So you can see in this that I have created two waveforms, which are 256 QAM 21 MCS. The first one is 100 megahertz and the other one is 400 megahertz waveform, and they are full RB. So for this demonstration, I have loaded first the 100 megahertz signal, and then you load it to the ARB and set the ARB as on, and then you go to basically measurement setup, where you set up the different parameters needed to demodulate the signal. So for this demonstration, right now you are seeing a 100 megahertz signal being demodulated, and I'm getting around minus 42.4 EVM when the input power is minus 10. And you can see my output port on the first head is RF SD1 and the input port is RF SD2. So I can set these to different frequency. So for example, I can set this to 26.55. So in the N257 band. So all you have to do is go to the source frequency and set that to the desired frequency, and then on the analyzer you can set the signal to the same frequency. So you can see that now the signal is being demodulated at 26.55 gigahertz. So similarly, with the same setup, all you need to, you can go to 39 gig band and 43 gig band. So let's choose another frequency in the 39 gig band. So I select 39 gig as the source frequency and 39 as my carrier analyzer frequency, and you can see my performance at 39 gig. And let me show you in 43 gig band. So say 42 gigahertz I set as the source frequency, and similarly I can set that to the on the analyzer side. So you can see that the same box with the same setup, everything, you can actually demodulate a signal in different bands. Now let's switch over to using a 400 megahertz signal. So all I need to do is I can go to the modulation setup and load the 400 megahertz waveform, which I have already created using Signal Studio, and set it in the ARP. And then you can basically save, I have before this demonstrations created this signal, and you can save the state file so that you don't have to go and set up in the measurement set up every parameter to demodulate a signal. So you can just simply go to screen config and state. So this is the one that I saved earlier. So I'll basically go and recall this. So this will basically go and set your all the parameters in the measurement setup, set your source, to 400 megahertz, set your frequencies, and then so here it is. So you can see this is the performance of the box at 400 megahertz. You can see the signal in the spectrum. It's a 400 megahertz signal, and this is the demodulation performance. So with this, I conclude the demonstration of E6681A EXM wideband and M1740 RRS solution for testing 5G FR2 devices in manufacturing. Thank you for your attention.